In this video, we're going to be sketching rational functions by hand. So here we have g of x equals negative 2x minus 1 over x. So the first thing that we want to do is we're going to find our vertical asymptote. And so to do that, we need to take our denominator and set it equal to 0 and solve, which we did. So that's going to go ahead and give us a value of x equals 0. Then we need to find our horizontal asymptote, which is our y equals. And to do that, we're going to look and we see that we have our numerator and our denominator have the same degree. So remember there is an imaginary 1 in front, and so we're going to take those leading coefficients. And so we're going to have a negative 2 over 1, which is really just negative 2. We don't really have any holes, so we have our vertical asymptote. So we're going to go ahead and we can actually sketch our vertical asymptote and our horizontal asymptote. So we'll sketch our vertical asymptote here at x equals 0, and we'll sketch our horizontal asymptote at y equals negative 2. And we're actually going to go ahead and create a table. So here we have our x values and our y values, and I want to make sure that we're including any holes or any vertical asymptotes. So because 0 is our vertical asymptote, we're going to go ahead from here and put some different numbers in. So our y is actually our g of x because that's the equation that we're using, so same thing. And we want two numbers larger than our vertical asymptote and two numbers smaller than our vertical asymptote. So I'm going to use negative 2 and negative 1 and 1 and 2. Then from here, I'm actually going to use my graphing calculator to get my table of value. So I'm going to plug it into my y equals. So I'm going to have a negative 2x minus 1 over x. I'm going to go to the table. So I'm going to go to the table function, and I'm going to see that for negative 2, I have a value of negative 3 halves. So I'll write negative 3 halves, and that's really just a negative 1.5. Then, for negative 1, I had a value of negative 1. We had an error at 0, which makes sense because that's our vertical asymptote. At 1, we have a value of negative 3. Oops, let's try that with the right color. Negative 3. And for 2, we have a value of negative 5 halves, which is going to be negative 2.5. And so now we're ready to plot our points. So we're going to go negative 2 and negative 1.5, and then negative 1, negative 1, and then 1, negative 3, and 2 and negative 2.5. And remember that to graph this, we want to graph nice smooth curves. So we know they're supposed to go close to our asymptote but not touch it in both directions. And same here, nice smooth curve, close to the asymptotes but not touching it. And now we've just sketched g of x equals negative 2x minus 1 divided by x. Let's do another one. So here we have the function h of x equals x divided by x squared minus x minus 2. So we'll start by finding our vertical asymptote, and we do that by taking our x squared minus x minus 2 and setting it equal to 0. So here we're going to end up factoring. So we're going to use x minus 2 and x plus 1 equals 0, which is going to give us an x minus 2 equals 0, or x equals 2, and an x plus 1 equals 0, which means x equals negative 1. So we're going to have vertical asymptotes at x equals negative 1 and at x equals 2. Let's take a look at our horizontal asymptote. So our horizontal asymptote, our y equals, if we take a look at our function, we notice that our top degree is a 1, but our base degree, our denominator degree, is a 2, meaning it's larger. So we want to rewrite this as a 0x squared plus x over x squared minus x minus 2. And remember that we have that imaginary 1 right there. So now we want to box these. And what is 0 divided by 1? Well, it's 0. So our horizontal asymptote is going to be a 0. So we can go ahead and graph our vertical asymptotes at x equals -1 and at x equals 2, and our horizontal asymptote at x equals 0. And now we're ready to make our table. Now this time we have two vertical asymptotes, one at -1 and one at 2. So we know we need a number before, in between, and after. So let's use -2, 0, and 3. I'm going to go ahead and use my graphing calculator again to get those values. So we're going to go alpha y equals, set that fraction, x over x squared minus x minus 2, and pull up our table. So when we're looking for a -2, we get a -1/2. You can write -0.5, that's fine as well. Now we already know that we're not going to get a value there or there because those are our asymptotes. So if we look at 0, we're going to see that we have a 0. And when we plug in a 3, we're looking at 3/4 or 0.75. I'm going to write this one as a 0.75. So I'm going to go ahead and graph those. So I'm going to have -2 and -1/2. And then I'm going to have 0, 0. And I'm going to have 3 and 3/4. Now what's hard is you're like, I don't feel like that's enough information. How do you know which way things should bend? Well, remember to use your asymptotes as a guide. This is supposed to be close to our horizontal asymptote, and then it's supposed to turn and come to our vertical asymptote. Remember to make, remember to make your curves though nice and smooth, which sometimes can be hard, as best you can. And then same thing here. I just want to make sure that we're curving nice and easy so that we're not having a sharp point right there, right? We don't want a sharp point there. Now the middle is a little more interesting here. So we can graph this with even just this one point left, right? Our 0 point. Now if you want to, if this is a little bit too stressful, you can go ahead and pick and plug in a 1 and see what that does, and that'll help you out too. But because my line finished down, that tells me that after the asymptote, I'm going to be up. So I'm going to come from the up, I'm going to cross over, and then come back down again. And then notice how I finished down, but when I move over to the next one, I'm starting at the up position and then moving over. Let's sketch just one more. So here we've got f of x equals x squared minus 9 over x squared minus 2x minus 3. Now the first thing that we want to do is factor it if that's possible. And it is. Our numerator will factor to an x plus 3 and an x minus 3. And our denominator will factor to an x minus 3 and an x plus 1. We're able to cross off our x minus 3's, which tells us that x is not going to be allowed to be the number 3, which gives us a whole, right? This means that we're going to have a whole. So we just need to find where our whole is at. So we're going to have a whole at 3, comma, what? So we just need to plug in with what we have left. And what we have left is x plus 3 over x plus 1. So we'll go ahead and we'll plug our whole in for that. So we'll have 3 plus 3 over 3 plus 1, which is 6 over 4, which is 3/2. So we'll have a whole at 3, comma 3/2. And now we want to find our vertical asymptote. So my vertical asymptote, I'm going to take my denominator and set it equal to 0. So I'll have x plus 1 equals 0, which means x equals -1. And then for my vertical asymptote, or sorry, my horizontal asymptote, I'm going to take a look, and they both have degree 1. So because they have matching degrees, remember that's an invisible 1 and an invisible 1 there, I can just take a look at my leading coefficients, and I have 1 over 1, which is 1. And I'm now ready to make my table. So this time, I'm going to go ahead and I'm going to put 2 spots before my asymptote, and then 2 spaces before the whole of 3, which we know goes with 3 halves. But because it's a whole, what we're going to do is we're just going to kind of leave this blank. And then 2 spaces after, just so you can get a feel for what that might look like. Okay, so I'm going to use -5 and -2 for before my -1. I'm going to use -1/2 and 1 between my vertical asymptote and the whole, and I'm going to use 4 and 5 for after. So let's go ahead and pull up our calculator, and we're going to go ahead and we'll enter in our equation. And because x plus 3 divided by x plus 1 is just the simplified version of our function, I'm going to use that one. So alpha y equals, and so x plus 3 over x plus 1, and we go to my table. And I'm going to see that when I plug in a -5, I'm going to get a positive 1/2. When I plug in a -2, I get a -1. When we plug in a -1/2, see, that's not there for me. So that might be one that I have to plug in myself or have it calculate for me. So if I go to my table set, I can say, would you please start at -0.5, then go back to my table, and it'll tell me that value is a 5. Then I'm going to go ahead and switch because I don't want to count by 0.5. So go back to my table set, and I can enter in a 0, and go back to my table, and get a 1. Now you might think that that's a lot to do, and if that's a lot to do for you, then you're going to want to just plug in that 1/2 by hand, or go ahead and exit out of it and plug it in, and that will help. Then we're looking for a 4, which is 7/5, and 7/5 is going to be a 1.4. And if we plug in our 5, we're going to get a 4/3, which is a 1.3 repeating 3, and then we can go ahead and plot those points. And we also need to make sure that we're plotting our intercepts, or our asymptotes rather. So let's do that first. So here we have our horizontal asymptote, now our vertical asymptote, right there. Then we can plot our point. So here we have our points plotted, but we do have our whole at 3. So 1, 2, 3. So right here we need to make sure that we don't draw anything right there, that our line doesn't go through that. And so now we'll make our nice smooth curves. And then here I like to start from the hole and work my way up or away so that I don't end up accidentally going into it. And then away. And we're done.